How do biochemical markers predict addiction severity? Imagine being able to peek inside the brain and body to see how deeply someone is affected by substance use. That's what biochemical markers help us do. They are measurable signs that tell us about the biological changes linked to addiction. These markers go beyond just knowing if someone has recently used a drug. They can reveal how severe the addiction might be and how likely someone is to relapse. One way they do this is through neuroimaging. Brain scans can show us changes in areas involved in craving and decision-making. For example, if the brain's gray matter in the insula is reduced, or if the activity in the ventromedial prefrontal cortex and anterior cingulate cortex is abnormal, it suggests a more serious addiction. These areas help control emotions, cravings, and impulses. When they don't work right, it's harder for someone to stay abstinent. Neuroimaging gives us an objective look at these brain changes and can predict who might struggle more with relapse. Hormonal and neuroendocrine markers also play a role. The hypothalamic pituitary adrenal axis controls stress hormones. When this system is disrupted by long-term substance use, it can make withdrawal more intense and increase relapse risk. For instance, if stress hormone levels are lower during withdrawal, it can signal a higher chance of returning to drug use because the body's stress response isn't functioning normally. Electrophysiological markers like the P300 event-related potential are electrical signals in the brain. A smaller P300 response in teenagers can indicate a higher risk of developing substance problems later. This marker isn't caused by drug use but may show inherited traits that make someone more vulnerable. It helps identify those who might need extra support early on. Genetic and epigenetic markers are about our genes and how they're expressed. Certain genetic variations can make someone more prone to addiction or influence how severe it might become. Epigenetic changes happen when substance use alters gene activity without changing the DNA itself. These changes can show how much damage has been done and how the disorder might progress. Biochemical signs of organ damage, like liver function tests in alcohol use disorder, also give clues about addiction severity. If these tests show damage, it indicates long-term, heavy use. While they don't directly measure brain changes, they help us understand the overall health impact of addiction. Using these markers together allows clinicians to get a full picture of how serious the addiction is. They can predict relapse risk, tailor treatments, and monitor progress more accurately. So, biochemical markers are like biological clues that help us understand the depth and danger of substance use disorder. They make assessments more precise and help guide better care for those struggling with addiction.